Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on how to predict the products of synthesis, decomposition, and combustion reactions. All right, so in order to predict the products, I first need to recognize what type of reaction that I have. So I have a little checklist that I made that I can use to figure that out. And then once I know what type of reaction, I can then figure out what the products are using my little chart down here. All right, so if I look here, I start with, are the reactants a CH and O compound plus O2? If the answer to that question is yes, then it is a combustion reaction. If the answer is no, then I come to the next question, which is there only one reactant? I can tell there's only one reactant because there will be no plus sign before the arrow. If there's only one reactant, it's decomposition. If there is not only one reactant, then I check to see if there are two reactants. If there are two reactants and both are elements, then it is a synthesis reaction. If that is not the case, if they're not both elements, then it's a replacement reaction, and I am not going to worry about that. So once I identify if it's combustion, decomposition, or synthesis, I can then look at this chart here to figure out what my products are. Combustion is the easiest because the products are always the same. It's always CO2 and H2O. Decomposition, because I'm only starting with one compound, I just separate it out into all of its elements. So I write each element separately, separated by a plus sign, and then I go back to check to see if it's a Brinkelhoff element. If it is BRINCLHO or F, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, or fluorine, I have to put a subscript of 2 behind it to indicate that it is a diatomic molecule. And then lastly, if it's synthesis, then it's just an element plus an element. So I use my rules for ionic compounds to find the formula. I go to the periodic table, I find the group that it's in, find the charge that corresponds to that group, do that for both elements. If they're the same magnitude, then they cancel out. If they're not, then I cross my charges. If you are unclear how to do that, then I would go back and watch the video on how to write formulas for compounds because I go through how to do that there. Okay, we'll start off with C3H8 plus O2. So for my checklist, I first check to see if it's a CH plus O2 compound, and it is. Hooray and huzzah. That means that it is going to be a combustion reaction. Right, so if it's combustion, the products are always the same. The products are CO2 and H2O. So once I have my products, I need to put it all together and I need to balance it. So I always start with the reactants. I started with C3H8 and O2. And the products I have here are CO2 and H2O. So I'm going to balance this rather quickly. If you're having trouble balancing equations, then I would go back and watch the balancing equations tutorial. All right, so this is a chew problem. It's got C, H, and 2 O's. So I'll start with whatever I have the most of. I have hydrogen. I have 8 of those on one side, 2 on the other. So I need 4 to balance the hydrogen. Carbons, I have 3 on one side, 1 on the other. So I'll need a 3 there to balance the carbons. Now I count my oxygen. I have 3 times 2 oxygen is 6. I have 4 times 1 oxygen here is 4. So that gives me a total of 10 oxygen on the product side and 2 on the reactant side, which means that I need to multiply this by 5 in order to get 10. So 3 carbons, 8 hydrogens, 4 times 2 is 8 hydrogens, 2 times 5 is 10 oxygens, and I counted 10 over here, so I am balanced. All right, so if we write that out, I get C3H8 plus 5O2 yields 3 CO2 plus 4 H2O. All right, let's do another. So I have OCl yields something. So I go through my checklist. Is it a CH plus O2? It is not. Is it only one reactant? It is only one reactant because there is no plus sign here. So when there's one reactant, it is decomposition. So the products of a decomposition are just the elements that make up that compound. So I have O and I have Cl for chlorine. All right, and then I check to see if they are Brinkelhoff elements. And O is a Brinkelhoffer, so I need a 2 here. And chlorine also a Brinkelhoffer, so I need a 2 there. If neither of these elements had been in Brinkelhoff, then I would just leave them by themselves, but because they're Brinkelhoff elements, I have to put the 2. All right, so now I'll balance. 1 oxygen, 2 oxygens here, so I'll need to put a 2 here to balance that. I have 2 chlorines here, and I have 2 chlorines here, so I'm balanced. So my final equation, okay. Let's look at another. Here, it is not a CH plus O2 compound. There is not one reactant because I have a plus sign. That means that there are 2 reactants. So that means that this is synthesis. So for synthesis, my product is based on my charges, right? So Zn is a transition metal. So I look at the back of my periodic table and it says that Zn always has a 2+ charge. And then As is arsenic. It's in group 15, and everything in group 15 has a 3- charge. So 2 and 3 do not cancel. So I move the 2 over, I move the 3 over, and then the pluses and the minuses go away. So I am left with Zn3 As2. All right, so now I balance my equation. So I have 3 Zns on the product, 1 on the reactant, so I put a 3 here. 2 As's on the product, 1 on the reactant, so I put a 2 here, and that's all I need to do. So I get 3 Zn plus 2 As gives me Zn3 As2. Let's look at a couple more. B3N5, this is not a CH plus O2 compound, and there's only one reactant because there's no plus sign, so this is decomposition. And the products of decomposition are just the elements. So the elements I have here are B and N, and then I have to check Brinkelhoff. B is not a part of Brinkelhoff. Br is a part of Brinkelhoff. Those are 2 different elements, so I don't need to do anything to the B. N is in Brinkelhoff, so I'm going to need to put a 2 here. So my products are B plus N2. All right, now let's balance this. All right, I have the most N's, so I have 5 N's here and 2 N's here. So the least common multiple here is 10. So 5 times 2 is 10, and 2 times 5 is 10. All right, and now that means I have 6 B's, so I need to put a 6 here. So I get 2B3N5 yields 6B plus 5N2. Next up, Na plus F2. This is not CH plus O2. This is not one reactant because there's a plus sign. It's 2 reactants, both elements, so it is synthesis. So for synthesis, I need to either cancel or cross my charges. Na is in group 1, so it is a 1+ charge. F is in group 17, so it's a 1- charge. Whenever I make a compound, I unbrinkelhoff. So I just ignore the subscript here, and that goes for any subscript that is part of any compound whenever we are doing synthesis. We don't need to put the 2 here because it's not by itself anymore, it's part of a compound. So no subscripts come with the charges here. I wait to see if I need to cross charges to put any subscripts. In this case, I don't need to cross charges because they cancel. 1 plus 1 minus cancel. So my product here is just NaF. Right, so now I'm going to rewrite this, and when I write it, I do have to put F2 because it's part of my reactants. So let's balance this. Right, I have 2 F's here, 1 F here, so I put a 2. That gives me 2 Na, so I put a 2 here, and I'm done. So I get 2 Na plus F2 yields 2 NaF. Okie dokie. Let's do one more. C2H6 plus O2, it is a CH plus O2 compound, so that means that it is combustion. And my products are CO2 and H2O, and I don't have to do anything at all except for balance this. All right, so this is a chew problem, so I start with whatever I have the most of, save the oxygens for last. So I have 6 hydrogens, 2 hydrogens, put a 3 here to get 6. And then carbons, I have 2 here and 1 here, so I'll put a 2 there. So if I count my oxygens, I have 4 here and 3 here, which gives me a total of 7. 7 is not easily divisible by 2, so essentially what I need to do is just go back and multiply everything by 2. So if I multiply the C2H6 by 2, 2 times 2 is 4, and 3 times 2 is 6. So now I have 4 carbons, 4 carbons. 2 times 6 is 12 hydrogens, 2 times 6 is 12 hydrogens. But what it's going to do is give me an even number of oxygens. So 4 times 2 is 8, 6 times 1 is 6. That gives me 14 oxygen, which means I can put a 7 here. So 2C2H6 plus 7O2 yields 4CO2 plus 6H2O. If you're having trouble with the balancing part of it, again, go back and watch the balancing equations video, and that will help give you some clarity about that. All right, so that is how we predict the products of synthesis, decomposition, and combustion reactions. This has been another episode of Chemistry with Wikipedia Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.